All right, so in the last video, made some progress and almost have the scoring solved. If you have seen the previous video, then you know that the 1 and 2 player scores are being combined and displayed in these 4 digits here. That is supposed to be the ball count for the player 2 and the score for the player 2. For some odd reason, these 2 digits are being used for the player 1 score and those 2 digits for player 2 score. Thought it was going to be on this schematic. Thought it was going to be one of these chips or one of these chips. All these have been replaced and tested, whatever. Pretty much not going to be that now at this point. So I've been thinking about this. The position of the score digits and the ball digits will be a function of the V and H values, okay? These values are derived from the clock chain circuitry. The clock chain circuitry, if you look at that, let's see. If you look at the clock chain circuitry, those values have a tick in the description or designation. So like 8V tick. And on these guys, where I'm focusing my efforts, don't have a tick. So where do those come from? Well, they're derived here. 2 counters or 2 counter chips are used, and exclusive OR gates to derive the non-ticked values. So I've tested these with a scope, and I've looked at these, and there were no obvious output, bad output on any of these chips. So it has to be one of these adders, one or both of these adders. So that's what I'm going to be replacing next. I'm thinking these are causing the designations at the position for the score digits to be wrong. So yeah. That's what we're going to do. I should have these chips, but where they are, I'm not sure. So let me go see if I can dig a couple of them up, and then I will be back. Well, I replaced both of these adders, and not fixed. Made absolutely no difference. So I'll put the old adders back in there because they're going to be good, and I will continue to study the schematics. Really thought that might do it because those adders do like to go bad. Those adders like to go bad to where you can't tell what's going on. I'm going to scrutinize those 7486s next to make sure everything looks good with them, but I think I've already done that, and they all look like they were okay. So anyway, moving forward. So it's been a few days since I've last looked at this board, trying to repair it, and I was just probing around tonight trying to figure out what the heck is going on, and I made a discovery on the Atari schematics. This flip-flop here is what is used to set the bricks for the wall, to initialize it, if you will, to fill them all in at the start of a game or start of a player. This chip, it does correspond to the chip on this board, but it's wired differently. This data line on the flip-flop is not pulled to 5 volts, it's tied to ground. So this functionality is going to act differently on this board. So I'm thinking that the bricks appearing when you serve the ball is correct for the Venture Line breakthrough board. I think that is a design difference between Atari and Venture Line's boards. So that is no longer, I don't consider that a fault. That's just a feature. That's just the way it is. Now, I built up some more of these little cheater boards that replace the 9312 Fairchild 8-to-1 decoder chips with replacements, the replacement boards that have 74 151s in it. I soldered in 74 LS 151s, which are quite a bit slower than the 9312 devices. The 9312s have an access time of about 30 nanoseconds typically, and the LS parts are more like 50 or 60 nanoseconds, so basically double It takes twice as long to propagate the signal through the chip. So that that is why I can't use those chips in these positions with 74LS technology. So I have them in there right now so I can demonstrate what it looks like. Basically, they're so slow that they can't form the characters. You see, these are supposed to be zeros or some number that you can read, and they're just garbage. It's because they can't respond fast enough to draw the numbers correctly. But I made a discovery by putting those chips in here and putting the bad chips. These are probably both bad, actually. These chips were originally here, by the way. So I moved them over here into a less significant position so that I could test to see if this number here is going to be affected when the ball is hit, even though I can't read it. So let's give it a shot and see what it does. So that's what zeros look like now with the screwed up chips in there, or with the slower chips. Okay, you see that? That number there, which is the ones digit for the first player, correctly changed, and it looks like it's a 1. It's trying to draw the 1. So that tells me that these chips are bad, okay, and I need to get faster 75 or 74 151s here. So I've ordered some 74S Schottky technology, which is going to be the fastest I can get, more than likely, for a TTL 151, 74 151. So I'll get those. I've built up 2 sockets. Here's one of them that has a socket, and here's the other. So when I get the 151s in, I'll plug 151 Schottkys, 74S 151. When I get those in, I will populate these 2 boards with those, and maybe I'll build up more if these turn out to be too slow too, but I think they're okay in this position. And then I will test, and hopefully that will let me finish this project. This is taking longer than I thought, but it's pretty challenging when you don't have a processor, you know. Anyway, I will continue on this, but that's where we are. I'm hopeful.